Hello students, now we are going to start 17th unit of your crash course, Dual Nature of Matter and Radiation. Basically, in this unit, only two concepts are there. One is photoelectric effect in that Einstein's equation. Number two, de Broglie wavelength. But every year they are asking question from this unit. A very small and very important unit it is. So we are going to discuss this. Actually, this unit is a part of electronics. Electronics means dealing with electrons. You can eject electron from matter in three methods. Every conductor has free electrons. They have sufficient energy to move within the matter. But if you want to eject the electrons from the matter, you have to supply extra energy. We can supply this energy in the form of kinetic energy, bombarding of alpha particle. Number two, you can supply by heat energy. Diode valve are based on that. You can supply in the form of light energy. Photoelectrons are the example of this, and photoelectric cell we are using nowadays. So what is happening when electrons, free electrons are moving within the matter? They have no sufficient energy to come out from matter. If you supply in the form of light, it will absorb that radiation. Now they got energy. They will come out of the matter. For each matter, there is a minimum amount of energy which electron needed to come up to the surface, and that amount is known as work function, denoted by phi naught. So what energy you are supplying in the form of photon? We know that photon has energy h nu. From this part electron will use to come out of surface, means you will get a zero energy electron on the surface, and remaining part it will use as kinetic energy. It will come out of the surface, but if you want to remove it from and you want to use this electron for current, you need one positive potential. With positive potential you can attract it. So now what we got? We supplied energy h nu. It divides into two parts. One part took electron from inside to surface, and second part it supplied electron kinetic energy. But we know that energy we can write in the form of h and nu, so we can write this also in that format, h into nu. H is constant, known as Planck's constant. We know that its value is 6.63 into 10 to the power minus 34 joule second, value of h. So the frequency which is associated with phi naught is known as threshold frequency. Nu naught is known as threshold frequency. Means minimum energy, minimum frequency which can eject electrons from the surface, minimum frequency, plus half m v square. You can write in this way also, h nu minus nu naught. It is known as Einstein's equation of photoelectric effect. This effect is known as photoelectric effect, and the matter from which you can eject electrons with the help of light are known as photosensitive substance. Photosensitive substance means it is not happening everywhere कि light is falling on this table and you will get electrons. No. If you want to eject electrons, you need that amount of energy which light cannot give to it. So that's why the photoelectric effect, this phenomena is related to a few metals which are known as photosensitive material. So it is the minimum frequency, threshold frequency. But we know that frequency is equals to speed upon wavelength. So we can write in this form also. Frequency means speed upon wavelength. Wavelength related to threshold frequency is known as threshold wavelength. It is the maximum value of wavelength which can eject electrons from photosensitive substance. So it is lambda naught, means threshold wavelength. Remember, it is the minimum frequency which can eject electrons. It is maximum wavelength which can eject electron, because energy is inversely proportional to wavelength but directly proportional to frequency. So maximum problems which you are getting in your exam are based on this, or one concept is also there कि when we are doing this and when we are increasing the intensity of light, what you are doing by increasing the intensity of light, you are increasing the number of photons. If you want to eject one electron, you need one photon. And this effect also proves the wave particle nature of light. Because if electron is coming out from the matter, electrons are particles, they have mass 9.1 into 10 to the power minus 31 kg. If one mass hit another mass, only then he can supply momentum to that mass. If photon hit the electron and throw it out from the matter, it means photons are behaving like a particle. Getting my point? Photons are behaving like a particle. So what photoelectric effect's purpose? Its purpose was to establish the dual nature of light. Light can behave as a wave as well as a particle. So when we are increasing the intensity, what we are doing? We are increasing the number of photons. More photons, more photoelectrons you will get. If you are making intensity double, means now number of photons is double. So you will get double photoelectrons. But after one time, there will be one limit. If 100, suppose I am saying not 100, suppose 100 free electrons were moving here and there, and all are coming now in circuit, they are moving in circuit. So after that, if you are putting more photons, you will not get extra photoelectron. So that current is known as saturation current. But in place of intensity, if you are increasing the frequency, it means you are now increasing the energy of photon, not number of photon. If you are only increasing the frequency, you know that photon's energy is h nu. Means now you are increasing the energy of photon. Photon is 1. After increasing the frequency, it will not now it will be double. 2 photons are coming because we are throwing more frequency light. We increased only frequency, so number of photons will be same, number of photoelectron will be same, but only photons will come with high energy. So they supply high energy to electron. So electron will come out with high kinetic energy. Means if you are increasing the frequency, you are increasing the velocity of ejected electron. If you are increasing the intensity, you are increasing the number of photoelectrons. Keep in mind. So only these concepts were there. After that, when we proved the dual nature of light, which was thought initially that it is a wave, now it is behaving like a particle also. De Broglie thought if with wave momentum is associated, which is purely a property of particle, so each particle should be associated with one wavelength. This wavelength is known as de Broglie wavelength. What is it? It is known as de Broglie wavelength. He gave idea theoretical only, but Davison and Germer, they proved it experimentally. And nowadays, this idea we are using in electron microscopes. He proved experimentally that fast moving electron can be used as waves. He calculated the wave of fast moving electron when he applied a 54 volt potential difference on them. He got wavelength of electron 1.65 angstrom. Experimentally he proved that with fast moving electron one wave is associated, and experimentally he got the wavelength. He did experiment by Davison and Germer. So that photoelectric effect nowadays we are using in photocells, where we are converting light energy into electrical energy. We are converting light energy into electrical energy. So it was all about the concepts of dual nature of matter and radiations. Only on this you will get one problem. So we will do similar types of so many problems which they asked in your previous year papers. From 2010 to 2019, I covered in my theory parts, and from 1998 to 2010, I am covering that part in crash course. If you are going with full course, you will get 31 year problems based on each topic. A huge amount of problems which will help you, which will prepare you for your exam for a good rank. So now we are starting our 45 problem assignment on these small concepts